All right, it's the top of the hour. Hello, everyone. Welcome and thank you for joining us for Tech Tuesday from Vic Myers Associates, this week in partnership with PMC Engineering. My name is Ryan Christian, and I will be the moderator today. Just a couple housekeeping items to get us started. First, if you have any questions, please feel free to use the Q&A section or the comment box. We're happy to answer those at the end of the presentation. We will send a link out to all attendees so you can share with your colleagues, or perhaps if you just want to review the content again at a later date. You can also see this content and more on our website at www.vicmyers.com in our resources section. The topic today is use and selection of submersible hydrostatic level sensors in the water and wastewater industry. This will include a focus on ground, surface, storm, flash flood, and brackish water. Also, we'll feature some applications for general wastewater and landfill as well. Today's topic is presented by our panelist, Rob Knowles, CEO of PMC Engineering. Rob's entire career has been associated with sensors and their design and development for use in a wide range of application and industries. Born in England, he first became associated with sensor technology with the development of unique LVDT products for online measurement of precision components. Then in later years, after moving to the US in 1981, his focus has really been on pressure and other technologies specifically for test and measurement and water-related level transmitter products. Rob first came to recognition in the water industry by being involved in the type of products we're discussing today in the early 1980s. He's currently the CEO of PMC Engineering in Connecticut, but is also very well known for establishing the Druck brand of precision pressure sensors throughout North America. So from all of the Vic Myers team, our local customers, thank you, Rob, for your time today and sharing your expertise with us. We really appreciate you do this. I'll unmute you now and you can take it away.
Hello, everybody. Yes, as Brian said, Rob Knowles is my name. I'm from PMC Engineering in Danbury, Connecticut. And to be very frank with you, I think I'd rather be located somewhere where you are than I am here pretty close to the New York area. But we're managing, and PMC is working effectively and well without any problems. And we can certainly supply the products that we're going to be talking to you today straight from the factory here in Danbury. So just a little bit of background here, which is sort of related and interesting. When I first came to the US, Ryan mentioned that, I actually spent a fair bit of time in the early 80s with the Vic Myers technical engineers, and I've worked with them ever since. And it's an outstanding company to work with because it offers, the company offers exactly what we offer at PMC, which is technical support, strong technical and engineering support. And I'll be mentioning several times during this presentation that this is not a commodity product. People consider it as a commodity product, but it's not. It's heavily engineered to suit the various applications that are required. And my association, not just with Vic Myers, I started back in 82. I did a presentation with the NGWA, the National Groundwater Association, in Las Vegas, and I was really pulled down badly because I was busy telling people how good these sensors were, and they were busy telling me how bad they were because they were never built to be used downhole and fully submerged. We took that to heart. We learned a lot. I particularly remember working with somebody at the Bureau of Rec in Colorado and telling me that the cables all stretched, which made them effectively useless. And he used to hang the sensors out, or transmitters outside of his window or over the cliff and let the PVC stretch in the sun for quite a few weeks before he put them down the hole. And that led us to putting Kevlar in the cable, and we were certainly the first people to put or design Kevlar into the cable where you get basically a no stretch situation. A second thing that happened in your territory was in Albuquerque in New Mexico. We ran into one of the competitors' products failing, many of them failing in the city, and that was due to water hammer. Another thing that we generally don't talk too much about, but yes, water hammer will very definitely blow up one of these level sensors, and you need some sort of feature inside the product to protect against it. So we learned from the city of Albuquerque. And the third one that I recall was very early in the 80s that we worked with, was back up in Colorado again, round the dams, I beg your pardon. And there were tons and tons or lots of half-inch standpipes. And we designed what you will find in our catalog as a product called the MTM 3000, which is a 3/8 of an inch diameter product, which now sells globally very effectively, but it all started in Colorado. So I have a lot of fond memories of the territory, and that's just a little bit of background. And I want to give you the understanding that we go back a long time in developing these products, and we have therefore real live experience of the reliability and so on that you're looking for from them. So we're going to quickly go through this agenda, the techniques that can be used, but we're going to be focusing on the hydrostatic measurement, what to look for, the product, the principle and the technology, just touching on that. Some of the performance features that are available in the products and the specifications, the range of PMC products, general applications and products that we address, because people come from so many different spheres, you can't focus on one like you would do if you were sitting in a lab face to face. You'd focus on that particular application. Couple of major applications that we've recently been involved in, which show the breadth of our product line and the customization capabilities that we have. And that is strong and very important as well. And finally, how we get out to you guys, which is through a newsletter. And at the end, as Ryan said, any questions that might come up. So there are other techniques than hydrostatic, and certainly not going to discuss these, but having said that, you may have run into these: ultrasonic, radar, bubbler systems, been used forever, conductive tape, not very accurate, but it's reliable, vibrating wire is an old technology that still is used in certain applications, and even the old basic staff gauge with a measure coming up out of a pond, and sometimes these days with a camera. All those do the same sorts of things. Our focus is hydrostatic pressure. For us, it's because we are a pressure sensor manufacturer. As I just said, going right back to the 1980s, learned and developed how to make these things as reliable as possible. The other name they're sometimes known as is piezometer, but at the moment we just focus on hydrostatic pressure. So what to look for? What are your prime objectives when you're looking for any pressure hydrostatic? Well, I already said it, I'm saying it again. Don't view it as a commodity. Don't get on the phone and say, oh yeah, I just want a pressure sensor to measure 100 feet of water down in the well. Just give me your best price and your best delivery. Not the way to buy these things. You really need to understand what is in that water. It may not just be pure water. What other requirements you're going to need, what sort of reliability you're going to be looking for it, and talk to one of the VMA people or talk to PMC, because we can talk you through the best product to buy and what we can do. And if our product won't do the job, we'll tell you that as well. If it's better done with a different type of technology, then that's the way we point you. But there are probably 10 to 12 manufacturers that offer these products. And the only thing that I can fairly say is not all designs are equal. And that's as far as I'm prepared to go. I think that products are built differently. So the three key things to consider are in the following order of priority. A, reliability. You're putting the sensor generally out of sight, sometimes in an environment that you're not too sure about. You want reliability. Do you want 1 year or do you want 10 years? Well, I can probably say that if you get a product to last more than 1 year or 18 months, it will probably last 10 years. Too many times we see customers selecting a sensor, installing it, and then it fails for various reasons after 18 months. So they buy another one, and they just get used to the fact that this is a product that's going to last somewhere between 1 and 2 years. Well, that need not be the case. And what PMC tried to do is to make a product that's going to last you 10 years. And there are all sorts of reasons why it should last you 10 years, one of which includes the way you install the product. Secondly, maintenance. These products for sure require some level of maintenance as long as you understand what is needed to be done, but the maintenance can be a problematic one. If the sensor's placed out in the wild somewhere, it's difficult to get to, and so on and so forth. So maintenance has a cost of ownership, as it's known as, and that's another consideration that you need to consider. And the third thing on the list is price. And I can't say that we are always the lowest cost supplier, because that's not the case. But when you weigh up the two things above, maybe we are the lowest cost supplier. And that's where talking to the engineers at PMA or at PMC becomes a thing that we would always encourage you to do. Don't just buy it from a catalog or offline. Actually talk to a live voice of somebody who really knows what they're talking about. So reliability. What's the goal? Well, we think the goal should be a minimum of 10 years. Why? Because that's what a product like this should last for. The technology inside the product is well capable of lasting 10 or 20 years. It's the same product that goes inside sensors that are built into aircraft that have incredibly long lives. The MTBF, that's the mean time between failure of the PMC products, is extremely long. The design of the sensor, very, very long life. It's a solid state sensor. The materials we use, titanium especially, are extremely reliable in the applications. So 10 years is not an unreasonable goal to aim for. The cable connection is one of the major keys, and we'll talk a little bit about that more than once during this presentation. The cable connection has got to be done in a way in which it's reliable, and to do that you need to minimize the number of different materials that you make the cable connection to the body with. In our case, we only have two. We have the outside layer, and we have the titanium or stainless steel. And the way it's designed, it should seal for a very long period of time. Third thing on reliability, we mentioned water hammer, and that indeed is a question. That is the sensor going to be placed in a place where there could be water hammer developed from a pump or some other type of metallic knocking noise, which will send shock waves through the water and be seen by the sensor as an incredibly high pressure, way above any overpressure or proof pressure that the sensor might contain. There are ways in which we incorporate into all our sensors that actually protect. Maintenance. Well, the goal would be zero maintenance through the lifetime of the product. So how do you get zero maintenance over 10 years? Well, one thing, and for sure the most relevant one that people run into, is where the breather, and it has to have a breather, we'll sort of touch on that in a minute, but it has to have a breather to the atmosphere, so you get a balance between the changes in atmospheric pressure and the pressure that's on the top of the water or the pond, lake, where it is. And we cannot afford any water or humidity going down that breather tube. Firstly, it will block the breather tube, which will nullify the effect of the breather tube. And secondly, eventually it will find its way down inside of the sensor. And it might take quite a long time if it's a lot of cable, but nonetheless, it will find its way down there. So you have to protect it. We'll talk a little bit about what you can do that, but for sure at PMC, we offer a solution to that, which is lifetime. And that gives you zero maintenance, at least from the breather side. The other concern over maintenance is recalibration. All pressure sensors drift, And if any sensor salesman comes along and tells you that they don't, then he's not a sensor salesman. They will all drift to some degree. The more money you pay, generally, the less they will drift, which means that they'll stay within the accuracy levels that you wanted for a longer period of time. The higher the accuracy that you buy from the sensor, it means the starting point to drift is going to be that much better, so it will stay within the accuracy needs for a much longer period of time. Most applications in water level really don't need very high accuracy. There is a perception that they do, and there's certainly applications in large reservoirs and so on where high accuracy is important, but most of the time it's not. It's probably 0.5%. It may even be in the wastewater measurements, may even be 1%. And for sure, the correct sensor selected for jobs such as that will probably last on the calibration side as well as the breather side for 10 years. Calibration drift does not just go linearly. It's quite fast initially, and then it starts to level out over time. So you see on a data sheet 0.1% per year. Yes, that will be right. That will be right for the first 1 or 2 years. But as time goes on, it won't be as high as that, and it may even start to drift in the other direction. It's not a very predictable part of the specification, but a high integrity product like PMCs is not going to drift very far. We have tons and tons of records and data to show that. So what's the principle? Well, to start with, I just want to remind everybody that what happens is the sensor is put down below the water level, and then the pressure of the water on the sensor, which is at the pressure sensor sketch on the right side of the picture, is raising the pressure, and you'll measure the height between where that level is and the water level at the top. However, the atmospheric pressure will change, and in the ideal sensor, you'll do exactly what it's shown here. The atmospheric pressure will bear down on the breather that goes right back down to the sensor on the inside, and it will also bear down on the surface of the water. Obviously, the two will be equal, so it becomes irrelevant. If, on the other hand, you block or don't have the breather, then you're going to have the atmospheric pressure adding to the pressure of the water, and you're just going to start to get erroneous errors. The other thing you can do, which is not totally uncommon, is to not have a vented gauge sensor. Yes, that's much more reliable. You have either what we call a seal gauge, which is good for higher pressure ranges, or an absolute sensor, and you can measure the barometric pressure and put that into your data log or monitor that, and by subtraction, you can find out what the level is. The weakness of that, of course, is you've got two sensors to make one measurement, and therefore you've got additive errors on all the errors that make up the error of the pressure sensor. So, but it is an alternative. But that's the principle behind what we. This picture is going deep inside the sensor. That piece of silicon that you're looking at there is less than 1/8 of an inch from side to side, so it's very small, and you can see the thin piece on the middle is bending because of the pressure from where it's right in the middle. That's the pressure that will come from the water down onto the sensor. It will deflect the diaphragm, but as I said before, the diaphragm only moves about a few microns for full scale pressure, so it's hardly visible, but it does measure, and inside those two bendy bits, there are strain gauges which are ion implanted in the silicon, and there, as a Wheatstone bridge, that's what gives you the change. It's a change of resistance, and that's what goes off into the electronics, and they do their clever stuff in the electronics, and you get something simple like a 4 to 20 milliamp output. But that's the basic silicon chip that goes inside most of our sensors, not quite all. This picture shows the modules, which as we call them, where that piece of silicon is embedded in either a stainless steel or titanium construction. The one on the left is vented gauge. The one on the right is absolute or seal gauge. And we're not going to go into the depth of that. That's what your sales engineers are for. They can do that. I can do that, but we don't have the on from there. But that is that module, as we call it, is about 1/2 inch in diameter in most of the products that we offer in the Versaline range. So it's still quite small, and the little piece of silicon is right embedded in there. There's lots of other very clever micro machining and other very clever upmarket techniques and technologies that put. Just briefly, this is the ceramic capacitive sensors that we use for the wastewater and what we call the open face sensors, where the silicon isolating diaphragm, previous picture, is actually quite fragile. So it's relatively good embedded inside the nose cone of the sensor, whereas where you want the ability to have solids and other things bouncing past the sensor that you might get in wastewater, ceramic is the better technology. It's also very, very good in terms of minimal drift over a long period of time for very low pressures, and wastewater applications tend to be very low pressures. So we're now on to product features, and this is the picture which tells really and highlights the major construction parts of our sensor. This is the 3/4 inch diameter groundwater monitoring sensor, which can be put a long way down into a water well, and is the workhorse product of our product range. You can see, looking around that, the nose cone is referenced at the bottom. That is not just a piece of Delrin with a couple of holes screwed onto it. It is designed to protect against the water hammer that I mentioned earlier. You can see reference to the laser welding that we use. We use both laser and electron beam welding in our construction. Laser just sounds a bit sexier, but they both do the same job, and they're very effective because the whole thing is a welded device apart from where the cable goes in. We do offer a 5-year corrosion warranty on titanium. We've never really had any failures in titanium unless it's been in some form of acid in a tank, but in the water industry, we have not had problems with it. The electronics is solid state. I'll touch on that with the next couple of slides. Everything's fully potted. The breather comes out the back of the cable, which you can barely see. Oh, you can see the cable up there. The breather comes right up to the surface. That's the we call the vented cable. The Kevlar, I touched on Kevlar before. That's an integral part of the cable. It has a 200-pound breaking strain, and it does not stretch at all until it gets within 3% of that 200 pounds. So it's an excellent material, very, very strong, and that runs throughout the cable. So you can pull pretty hard on it, and usually if the product is stuck somewhere, the cable will come out, not broken, but with the back end of the sensor somehow. So, but hopefully you don't have to pull it out. The injection molding process, you'll see on the next slide. Diameter, we've just mentioned, in this case is 0.725, which is a little less than 3/4. The point of this really is that this will go down a 1-inch hole, a well with a 1-inch ID, and be able to go around any bends that you might see in there. And it's generally manages to do that. If that doesn't work, you have to go to the 3/8 of an inch diameter, where we are unique with that product, and use that one. But these products tend to be a little bit more expensive as they get smaller. That's the opposite to some things, but small size means slightly higher cost. And there's a reference around the end there to piezo-resistive technology, which we referenced a couple of times before. So that's the features of all our products. This picture shows from the left, it shows what is important. This is the connection of the cable. There's a lot of, let's call them PMC design features in here that are not shown on there to avoid any ingress of water. Basically, what you see is the circuit board inside the housing, cable connected to it. On the left-hand picture, you show the potting that goes around the circuit board. That is potting selected to go around the circuit board and provide the breathing that circuit boards generally, especially 4 to 20 milliamps, generate a little bit of heat in them. So that potting is custom potting to suit the application, suit the product. The next slide shows where the external potting, which is basically the polyurethane material, starts on the inside of the product, and then it fills up, and by a molding process, which is actually a somewhat hand molding process. It is sort of automatic, but it's a process which is not the fastest in the world because of the curing process. We found accelerating the curing is not as good as letting it cure naturally, but that is what you get from the mold. And on the right hand two pictures, and the right hand one is obviously the product in its case, in its housing. So that's a build up of what is really one of the very, very strongest part of our products. And I say that many times, but examples of this have been at the bottom of the Pacific Ocean or low down in the Pacific Ocean for tsunami early warning systems for more than 20 years and continue to work, streamed from buoys at the top. And this technology, this same sealing has protected those devices. So it's something we're incredibly proud of. It does come out of the mining industry. We didn't invent it, we learned how to use it, and it's something that we do very well. Now a few things about the products. There's a series of sales slides here. And what I've done is I've highlighted things which I want to mention. This one features 24-hour deliveries. Not many people need products, but when you get an emergency, you pull the well and the sensors failed, people come off on the phone and they start to demand, or not demand, that's not a fair statement, but they ask for a 24-hour delivery, and we can do that despite the fact that the cable will be customized to the exact length that the customer has requested, and the sensor will be ranged to the range that the customer has requested. So you maximize the range of the application. If you're not buying it out of catalog, being a 10 psi or 20 psi, if you want 15.3 feet of pressure measurement, water measurement rather, we will give you that. And that's not difficult to do. We're set up to do that, and we can do it in 24 hours. So that's something we're very proud of, and it also highlights the 5-year warranty on the titanium construction. You can see on the right there the picture of the submersible sensor with a ceramic open face design that goes into that sink weight, sometimes called a bird cage, that ends up usually inside sewage lift stations. The specifications, don't want to hang too much on this because stuff you can read in the data sheet, but we can have ranges as low as 5 inches of water gauge, and we can with these products. Temperatures can go up to, our applications that go up to 250. The technology and the products are capable of doing that. The ones we make are not designed to go down 5 in freezing conditions, but they're not going to do too much measuring of water much below about 30 degrees Fahrenheit, as we all know. Very high proof pressure to compensate for water hammer. Accuracy can be a lot better than you see on the data sheets, 0.05%, 0.1% stability down at the bottom there, a very key factor. It is per year, it's always quoted as a per year, but over 5 years it's not 0.5%. It's usually probably more like 0.3%, which comes to the point I made earlier. This is the range of products that we offer. Sorry if it sounds like I'm rushing through this, but I wanted to just try and touch on each slide, and quite a few of them. I'm not going to discuss every one of those, but there's a family of products, some of which it's a classic, 20% of them requirements, and then we've got the specialist ones that crop up that are not quite so heavily sold, but they add to the portfolio to make us into the company that we want to be, the go-to company for this type of product. The L2000 series is the one I just talked about. It's flush mount, and it's designed to go clog-free. The L4500 is the product that was featured on the features slide, and we featured it as standard. It's made of titanium. We consider that to be far the best material, especially in groundwater. people admit that, they claim it's really clean and so on and so forth. And so titanium, in fact, if you want a stainless steel one, we can make it, but it's more expensive than titanium. And so we tend to push that, obviously, for reliability reasons. This is the little MTM 3000. It's the same features as the other products, except it's only designed to go in a half standpipe. Here's a version where we have a 90-degree cable coming from the side, and that can be laid into a waste pipe at the bottom of a waste pipe. The cable tacked down, coming out at 90 degrees instead of in a loop, which is what generally happens without that feature on it, and brings the cable round and up. We have an SDI 12 protocol there, and it reminds me of mentioning off a temperature as an output along with the pressure level. That is something that you want to talk to people about, but it's certainly an option and sometimes a requirement to avoid having These are what we call specialized sensors. These three, one of them at the top is capable of operating up to 250 degrees Fahrenheit, and we've just secured a very positive and strong walk where that temperature is a reality, and they've we can do better with the 0.1% and go to 0.05% with the one in the middle there, so that's a higher accuracy. And a second reminder that we can offer both temperature and level out of the. I'm not going to stick on this slide because there's a lot of features there, but there's a lot of different things that we can. Hopefully, by this time, I've given you the Art Smart protocol. These are a list of accessories that we offer, and the only one, their box at the top, we supply them as a kit sometimes, the T10 or the T11 termination boxes, lightning protection at the surface, which is far more better than trying to save the product. Lightning protection in it, anything you can do in the sensor, and there's somebody might claim there's some light pretty useless. If you get a direct hit on a well, then it's going to blow the sensor up, whatever you ever manage to do in a sensor, and you're far better off to try and do a much more rugged or robust protection at the surface. Cable hanger we supply, various sync weights, but the most important one there is this thing over on the left-hand side called the MP11. That is what you connect to the breather tube, and it gives you a completely isolated termination between the breather tube and the outside environment. There is inside there a sphere, a Mylar sphere, which contracts and expands with the change in barometric pressure, and it will not allow anything to pass through, but it will also not reduce the performance of the sensor. If you look to the vent filter, the MP11, which people use, then you're going to have and there's various other devices out there which will include something which is going to bellows, is what I was thinking for, bellows, which is going to make a really big dent in the accuracy and reliability and repeatability of the sensors. So they work, the bellows does, but not very well in terms of accuracy. If you have desiccants anywhere, you're going to have to go and replace them all the time. The MP11 should be good for the life of the sensor. Remember that 10 years, which I quoted earlier. So that's a very important part of what we talk about. If you install the product correctly, you get a very good long-term reliability. Now, these are a few applications. This is this could actually be a barometric sensor. This is available as a sensor if you wanted to get away from the breather tube. This sensor at the wellhead, measure the barometric pressure, and maybe for a number of wells, if they're pretty close together, like Runner and Danville, you probably only need one barometric pressure. So there are times when that might be a good way to go. Or other applications such as a bubbler system will need a pressure sensor at the head. We have a product for that. And then we have these various applications. I'm sure everybody knows what that is. Landfills and remediation. Landfills are definitely a big application for our product. The titanium construction has big benefits there, and we have had an awful lot of success in both of those applications. Wastewater, we touched on wastewater times. It's what I call service water, and the sensors are suitable for that. We have experience of applications, similar applications, irrigation systems. The biggest problem with those is they're generally looking for a very, very low cost sensor. Reliability and accuracy don't seem to be so critical. That may be challenging for PMC, but nonetheless, if you want something to work for a long period of time, we're the company to come to. And we don't wish to be known as a water level, sorry, we do not wish to be known as a data logging supplier, because that really isn't our forte. That's what we focus on. Nonetheless, we do offer a data logger that particularly sells well with miniature sensor nobody else has. So if you want a miniature sensor and you need it, again, is something you can talk to your sales engineers about. There's a couple of applications here. I said I promised I'd mention. This is not to go through. There's tons of stuff on this slide. Main thing here is that it was a huge advantage of all the things that we do at high temperature. This is down in the sewers of New York City. If anybody's deep down, there's a lot of high temperature applications, let's call it, for these products. We managed to make the breather system, sorry, the vent system, the MP11, to work at higher temperatures, and other features in this product as well. So that was a system that we supply there, and they're very, very pleased at finding somebody that can actually satisfy a need they've had for years. The LA County seawater system is construction, because what they're doing there is trying to protect domestic water supplies there's a whole load of background about this online. But that also takes advantage of the products that we offer, which not everybody else offers. A lot of landfills. There is a white paper that can be found on our website about sewage lift stations and the values of a pressure sensor. Only a PMC pressure sensor, any pressure sensor station, and there's a kit that we sell for a sewage lift station, so it's sold as a kit with a number of it. And one other application is landfills. There are a lot of landfills. Very anxious. Again, titanium is a major feature of the product. 3,000 active landfills in the country, 10,000 old ones, which are probably much more important to monitor than the new ones. Finally, we put out newsletters from time to time, probably once every 6 weeks, something like that, and we try to keep those full of information, not only of the products but white papers and the like. This one was a general purpose newsletter. So if you're listening and you're interested in receiving information from PMC, sign up through your rep or online. You can sign up online for a newsletter. Favorable feedback. I know sometimes want to be receiving newsletters, and you get people who unsubscribe. But in these types of newsletters, positive feedback that has suggested, so we provide that to our customers. So sorry that was a little rushed, but that's the end of it, folks, and I hope that's been of some use to you.
Thanks so much, Rob. I'm going to open it up for Q&A now. And I've also got some questions coming in here. So let me go ahead and just let these come in and we'll take a look. One question here about the delivery. Is that 24-hour delivery realistic?
Well, it is, as long as it's, I mean, there's always some criteria. We maintain an inventory of the popular, we do not hold in our inventory the finished product like you might be able to buy from a catalog. And part of that is because we really feel it's important to supply the correct cable length and the correct range. That way you can maximize the performance of the sensor and not want to cut the cable. We don't really encourage people to cut the cable. They've got to rejoin the breather tube and various other things like that, and we're trying to avoid that. So the answer is yes. The process needs to go overnight. So that's why it's 24 hours and not 8 hours. It's very, very difficult to do it in a day. So if you order at any time during one day up till about 4 or 5 o'clock in the evening, we can actually finish that sensor off and have it shipped the following day. So it is reliable.
Okay, thank you. Can you explain a little bit more how the bladder thing works and how you claim it provides zero maintenance?
Oh, well, it's actually extremely simple. Rather than have a bellows, which also you're trying to protect that breather tube from the ingress of water or humidity, and it's no good having some sort of filter in there because humidity will go through anything pretty well. It will go through the smallest micron filters. So you've got to provide a complete isolation between the two. We know that desiccant will absorb the water and that will help, but desiccant adds this problematic maintenance obstacle to the user. You've got to get out and change the desiccant. A desiccant that's fully saturated is completely useless. So this is a bladder. I hate to use this word, and I tried to encourage our salesmen not to use this word, but it's a little bit like a balloon that you put over the outside. We put over the outside of the breather tube, or at least the piece inside of the MP11, and it's sealed such, and it's slightly pressurized so that it's in the form of a sphere. And that will go up and down, it will expand and it will retract according to the pressure of the day. Because now what you've got is you've got a completely sealed, which is the breather that goes right the way down to the sensor, and the sphere that's inside the MP11, and they're completely sealed from the environment. And it will not go, it's a mylar, it's a selected type of mylar that we use, and the humidity nor water will go through that mylar. So it's absolutely sealed between the two, and it works. It works really well. It took a fair bit of development. It's very simple, like most clever things are when you actually look at it, but it's probably quite difficult to replicate. But that's how it works.
Fantastic. Is there a maximum cable length? And for long cables, does the breather still work if it's a really long cable?
The answer about the cable length is well, the first bit's easy. We actually hold in our inventory up to 5,000 feet cable length. So it's possible to put a 5,000 foot length on a sensor. In the water industry, I've never seen anything much more than about maybe $2,000, 2,000 feet, but 1,000 feet is probably a pretty long length. So we can supply up to 5,000 feet. If you came along and wanted quite a few of them, then we wouldn't have the inventory probably, and it might extend the delivery. But the cable length is not a problem, especially for a 4 to 20 milliamp device. However, unlike what many people would say, you could actually have quite a long cable length for a millivolt product, which doesn't sell very heavily, except maybe to people with specific data loggers. I remember Campbell Scientific as a manufacturer, a competitor now with pressure sensors, actually in the same neck of the woods that you guys are, and they used to use a millivolt sensor over a very long period of time. But to do that, you need to use more wires than the 2 that come from a 4 to 20 milliamp, or even the 4 from a conventional voltage. You need 6 wires so that you use the other 2 as monitoring. So you can go a long way. Long answer to a simple question. The other point about the breather is a very astute question, because the breather is very small. It is small because it needs to be able to respond. It needs to maintain, the smallest amount of volume that you can get down there. However, the response down that very thin, very thin breather tube is slow. And we have run into applications where it's really, really important to have a bigger breather tube going down a longer length. And what we can do is we can get the cable manufactured. It's made for us with a larger breather tube. And those astute amongst you might say, why on earth do you care about a fast response? Well, there actually are, and there may be in your locations, there are parts of the world, and Hawaii jumps to mind on that, where the barometric pressure changes very, very quickly. And by the time it's changed and it gets right down to the sensor end, you've got a lot of measurements that are not accurate because you haven't got the differential pressure there. So we can do something about the breather tube if it's a problem. The normal breather tube does the job okay. Length can be up to 5,000 feet. So those are my 2 comments on that, those 2 questions.
And what are the general pressure ranges again for your sensor, for the submersible sensors?
We can go down to 5 inches of water, which is very low. And that's with the ceramic sensor. It's better at those ranges than the silicon sensor. And we can go as high as 2,000 PSI, which I can't remember how many feet it is, but that's very deep. In fact, I don't think you'll find, well, unless you're in the ocean, you would definitely find that in the oceans, but you won't find that, as far as I know anyway, in a land-based groundwater measurement system. So it's anything. The ranges are massive. When you get up to the very high ranges, you do actually end up by having to thicken the case of the product. If you've genuinely got 2,000 PSI on the outside of the product, then we actually end up with a larger case diameter.
All right, very good. I'm out of questions, and I think that's going to wrap it up for today. Thanks so much, Rob, for taking the time to do this.
Well, thank you everybody for listening. And just remember, you need a good salesman to help you, always.
Thanks so much, Rob. Thanks everyone for joining us for Tech Tuesday in partnership with PMC Engineering, Vic Myers Associates. We thank you so much for joining us, and we'll catch you next week for Tech Tuesday.